Hello everyone, I'm Paul and today we're solving problem 3005. Count elements with maximum frequency. This is an easy one, so next I will show you how to solve this efficiently. We need to do exactly what the title says. Count elements with maximum frequency. So first we need to get the maximum frequency among these elements, and then we need to count the elements with the corresponding maximum frequency. So whenever we are counting frequencies, we can use a frequency map. And in case you know what a frequency map is, it's just a map where every key is a unique value representing unique values from this array, and every value is a count for this key. And what this represents is the amount of times that we see this key in this array. So we can just iterate every element in this array from left to right, and this is how we can build this frequency map. First we are here, so this is initially empty, and we can add key 1, and the value for this will be 1. And what this means is up to this moment we have seen number 1 time. So next we are here, we add 2 as a key, and the count is 1. Next we are here, so now we have seen number 2 times. Next we are here, so we add 3 with a count of 1. Next we are here, so now we have seen number 1 2 times. And finally we are here, so we add 4 with a count of 1. So now we have our frequency map, and we can check what is the maximum frequency among all of this. And these are the frequencies for each number. The maximum number among these is 2. So this will be our maximum frequency. So now we can move to this part, which is count elements with a frequency of 2. So we can just iterate every element in the map, and whenever we find a frequency of 2, we add the corresponding frequency to our result. So we have our result, which is 0 initially, and we are iterating every element here. So first we are here, and this has a frequency of 2, and this happens to be our maximum frequency. So we need to add 2 elements to our result. So this is now 2. Next we are here, and this has a frequency of 2, which is our maximum frequency. So we have 2 more elements to add to our result. This is now 4. Now we are here, this has a frequency of 1, which is not the maximum frequency, so we continue. Finally we are here, and this has a frequency of 1, which is not our maximum frequency. So in this case we return 4. And this is it for the approach. Time complexity will be big O of n, because we need to iterate this, plus the number of unique keys in the array. We'll call this u. And space complexity will be big O of u. So now let's go with the code, and hopefully you will get the idea. First we have to build a frequency map, so we can call this fm. This is a default dictionary with a default value of an integer for every key. Now for every number in nums, fm at n plus equal 1. So now we have our frequency map, and we can move to the next part. We need to get the number which corresponds to the maximum frequency among all frequencies. So we can extract the values from the map. This is fm.values, and the maximum, meaning our target, is the maximum of these values. The result is initially 0. We need to return this result, and here in between we can iterate every value for v involves, and if the value is different from mx, which is our target, we just continue. Else we add to the result the corresponding value. So this is it for the code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.